A client walks into a meeting and asks you to build a training course. Their goal? The salespeople just need to understand the basics of cloud computing. That word, understand, is a trap. As a learning designer, you obviously want your learners to understand the material, but there is no visible way to observe understanding happening inside someone's head. To translate a fuzzy internal state into a usable metric, you have to ask two distinct questions. First, what are they actually going to do with this information? And second, what bad thing happens if they don't know it? When you start by listing content goals rather than identifying real-world performance gaps, you end up designing solutions for problems the business doesn't actually have. Converting a vague request into measurable behavioral change requires treating instructional design like an engineering discipline. An engineered process doesn't begin with content. It begins by defining a specific, observable performance gap. Once that gap is located, you have to plot the exact cognitive requirements needed to cross it onto a strict set of coordinates. And finally, you align your delivery method with the natural timeline of human skill acquisition. Heavy cognitive loads require time to cure. Without this structural blueprint, training initiatives will completely fail to alter actual workplace behavior. This table provides a strict two-part test for validating learning objectives. You ask, is this something the learner would actually do in real life? And can I tell if they've done it? Take the goal of listing Dutch prepositions from memory. You can easily test if a student has done this, but outside of an exam room, reciting a memorized list is rarely a real-world task. It passes one test, but fails the other. Now look at the objective for a learner to understand the limitations of JavaScript. Evaluating tool limitations is a real-world need, but again, understanding is too broad to observe directly.
Here is the chart with the corrected JavaScript objective. We unpack the vague verb into an observable action, identify the best programming tools for a specific task, and state the reasons why. If an objective relies on unobservable verbs or rote memorization without application, it is invalid. You rewrite it until the true behavioral action is revealed. Defining the action is only the first step. Next, you have to determine exactly how much the learner needs to learn. This vertical axis maps the cognitive sophistication required based on Bloom's taxonomy. It scales upward from simple recall to complex creation and evaluation. The horizontal axis measures proficiency, how automatic the behavior needs to be. This uses Gloria Gary's scale, moving from basic familiarization on the left all the way to unconscious competence on the right. Unconscious competence happens when you drive a manual transmission. Your hand shifts smoothly, without needing to look or consciously think about the mechanics. Look at this graph, mapping a specific corporate objective. The red X indicates that a learner needs to analyze electrical schematics correctly, using support materials. That requires high sophistication, but only conscious action, not complete automaticity.
A single e-learning module or a one-hour class will only ever get a learner to the bottom left corner of this grid. Reaching those higher coordinates strictly requires multiple exposures, feedback, and distributed practice over time. This brings us to the absolute limit in instructional design: time, and the natural pace at which humans adopt change. This architectural diagram illustrates Stewart Brand's concept of pace layering. It models how different parts of a system adapt at entirely different speeds. The outer layers, like the arrangement of the stuff inside a room or the interior space plan, can be swapped out quickly and cheaply. The inner layers, the load-bearing structure and the site foundation, are stabilizing forces. They require immense effort to modify and change only over years or decades. You cannot rebuild a house's foundation over a single weekend, and you cannot alter foundational human behaviors with a quick instructional fix. We can apply this architectural framework directly to the cognitive skills required of a newly promoted corporate manager. This checklist outlines tasks for a restaurant manager. Things like approving timesheets or verifying table settings are fast skills. They possess explicit, black and white rule sets. You can easily write down the exact right answers. On the other end of the spectrum are slow skills, like ensuring a respectful environment or resolving employee conflicts. These rely on tacit rules and recognizing subtle human patterns built over years of experience. Fast skills can be solved with the equivalent of a throw pillow, a quick job aid, or a simple checklist to get the job done today. Slow skills require heavy structural support and practice over time. Attempting to solve a slow, tacit skill deficit with a fast e-learning course is a total waste of resources. It simply will not work. By combining the cognitive matrix with pace layering, we get a definitive learning design model. Low sophistication and proficiency skills map to the fast layers, but if a skill lands in the upper right quadrant, demanding analytical creation and unconscious competence, that target is inherently slow. When a client asks for a quick check-the-box module to teach complex problem-solving, this unified model gives you the exact coordinates to prove why that timeline is impossible. True instructional design means aligning the educational intervention with the specific skill's natural pace layer. There is one final, unbreakable rule to this process. These rigorous analytical frameworks are built strictly for the designer. They are never for the learner. This slide is the industry's worst habit, starting a course by forcing participants to read a bulleted list of pedagogical learning objectives. Delete this jargon. Instead, take your mapped coordinates and translate them into a real-world scenario or a direct challenge. Give them a mission. Effective instructional design entirely hides its own engineering. It simply places the learner directly in front of the real-world gap and gives them the exact bridge they need to cross it.